Hi all. Start with the next video of PCE. In this video, we'll see the what is the different types of ordering rules need to follow in the PCI controller. So in this video, why actually PCI is following ordering rules? What are the different packets it's generated and how which order it's sending from RC to EP side, from master to slave side. So which order we need to follow. So in a spec they mentioned some ordering rules. Based on that order only we have to send the packets from master to slave side or RCs to EP side. So before going to start ordering rules, like what actually different types of packets is generated, why it's came into the ordering rules, what are the blocking conditions. So we'll see why its blocking condition came into picture. So we'll see all the different scenarios in the subsequent slides. So let's take one example here. What are the different packets it generated as a TL layer, transaction layer. In a on previous videos I already explained what are the different types. Four different types of packets will generate in a TL layer. Those are the first one will be the IO, second one will be the config IO, second one will be the config TLPs, third one will be the memory TLPs, fourth one will be the message TLPs. Message TLPs. So in this video, in previous video, I already explained what are the different type of packets and what is meaning of posted packets and non-posted packet. So posted packets means let us you have a RC, you have a EP, you are sending the packets from RC to EP side. If you get any response from EP to RC side, that we call as a non-posted. Let us say you are sending membrane. You want to read the data from any device from to RC side. You are sending as a membrane packets. Membrane packets. You will get as a completion response with the data that we call as a non-posted. So whenever you don't want to expect any response, that we call as a posted. If you say any membrane packet is a it's a posted condition. Why it's posted? Because I don't want to expected any response. I don't want to reduce my performance. So performance condition, speed consideration, we are kept that membrane packet as a posted. For membrane we will use as a non-posted. If you say an as a IO will be the very small amount of data. If you say an a membrane packet, you will send as a bunch of data from your RC to EP side. If you want to expect for every packet, if you expect completion, what happen? The performance will reduce. That's why they kept as a posted. If you say an IO packet, the maximum that size of that TLP is a 32-bit addressing mode. The length will be only one, so 1D word. So that kept it as a non-posted because very small amount of data is present in the IO. If you say the config also we have a very small data. So what happen? You will expect as a completion. If you have a very small data, if even if you expect completion also there is no loss of performance. If you say a message TLP also they kept it as a posted request. I don't want to expect any completions from the message. So that's why they kept it as a posted. So in a conclusion, I want to tell the posted will be the membrane and message TLPs. In remaining all other packets will be the non-posted. So one more I want to tell as a before going to start ordering rules, what is meaning of flow control. You are let us you have a RC, you have a EP, you are sending the packets from RC to EP side. You are expecting some completion from EP to RC side. Let us take where scenario where you have a laptop, that will be the laptop. This is the processor in your RC we call. EP means any hard disk. In practical example, any hard disk. Let us take 1 TB space is there. So let us you want to store movie in your laptop to any hard disk. Let us that movie having a 2 TB. Let us assume that movie you want to send. movie you want to send from your laptop to hard disk with 2 TB. Is it is it possible to send that data from your RCTPT? No, because you don't have enough space. If you have enough space, then only you can able to store that data from that EP as a hard disk. If you don't have enough space, you cannot able to send the packets. You can able to store the data. So how it will know whether it is enough space is present in the 1 TB is present. So how it's knowing? This we called as a mechanism, we called as a flow control mechanism. So once you connected your hard disk with your laptop using that USB port, you will get to know once a reset is happen. Once a reset is happen, then link training will happen. Once link training is completed, it will start sending the configuration. While in the configuration you will get to like what is the total area, 1 TB is there, what are the profiles is present, what is the available area. So everything you got to know in the while doing as a configuration, if you call as a reboot. So in that situation only everything we get to know that a particular device is having this much space. So if you have enough space, then only you will get to know. So this is we called as a update. It's updating that EEP device. This is the enough space I have. This is we called as a updating the that this concept we call as a update flow control. The concept in the PC we call as a update flow control. If you have enough space, then only you can able to send. This is a queue. If you have enough space, then only you can send. This is a concept we call as a update flow controller. So let us say take example where scenario in a flow control mechanism by kind, because the concept the mechanism we call as a flow control. So the flow control mechanism will happen with DLL. In a previous video also I explained DLL, what is the DLL significant, and what are the packets will generate in a DL. So in the DLL we have a it's our own packets will generated that we call as a DLLPs. So DLLPs we will get to know what is the space is present, what is the available this is the packet of DLLP. By using DLLP we got to know like you have a RC, you have a EP, that that particular device is connected with assume as a space we have a, let's take as a four 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 divides. You have a RC, you have a EP. RC is connected through EP through that lanes. Let us take in EP side you have a four divide space. So this divide space is occupied here. So what is the header count? How many headers you can able to send the from RTC to EP side? Header count you can able to see here a header. In a packets in DLLPs you will see. Let us take I have a header count is 2. This is a packet is generated from DLLPs. So it's mostly linked with the ordering rules. So that's why I'm explaining. So here is a header assume as a header as a 2. Once reading data from EP to RC side, you got to like this we call as update flow control. In flow control update flow control you got to like you can able to send the headers as 2 and let us 4 divides as a the data payload you got. So from this you will understand this is the maximum data you can able to send using two headers. Let's take as a membrite. If you take as a one only, you can able to use a one header. If you are using two headers, but if you have a within a limit four divers, if you can able to use as a two headers also. So let us take, I want to use one header as a membrite. Let us take membrite. So what happened? Maximum you can membrite means you are writing the data. How much data you can able to write? Maximum four divides. This is the maximum you can able to write that particular packet. So this by using update flow controller you will get to know what is the space is available in EP side. So by EP will send EP will send that packets to continuously without blocking with the RC side. So what is the available space, um, what is the available space, how many packets you will send, this all about a flow control mechanism. So why it's came like if you have enough space, then only you can able to send. Let us I want to send as a 10 packets, 10 headers, but you have a only two headers. So what happened? First two headers only you can able to send. Remaining eight headers will be the blocked. Temporarily it's blocked. Once update again comes, again two or four next update you got like you can able to send as a four headers. Now you can able to send as a four headers. So what is the maximum available area? How many packets you can able to send? How many headers you can able to send? You by it got to like by using DLLPs. This is a way packets will be blocked. So if you have enough space, then only you can able to send from RC to UP side. So in that scenario, what happen if you are sending different packets? You have a different DLLPs, different space will be there. So in that scenario, once packet is blocked, let us take membrane membrane packet is blocked. So in that situation, you're able to send the membrane packet or not. So let us take whenever scenario where RC will say you have a two headers, you have a four divided as a data payload, you have a RC, you have a EP. RC will send as I told four different packets. Let us assume scenario seven membrane, three membrane packets. Seven membrane, membrane packet. Three will be the membrane packets. So what happened? Which packet will send? So the I got to like headers will be to four divides of the data. So headers means you can able to send. Let us assume you are sending as a membrane packets first. So this is the we call as a posted. So, next, we, once the two headers is completed, right? So headers count will be the zero. So next packet, are you able to send the membrane packet, hard packet? No, right? It's not be the case. You can able to send. How you can able to send? So these are the concept we'll say as a ordering rules. Let us see here is a seven packets. So one packet, second packet, third packet, fourth packet, sixth packet, seventh packet. These are the membrane packets. Membrane packets. Eighth packet, ninth packet, 10 packet will be the mem membrane packets. So update flow control you got as a membrane packet is two. So next the remaining five will be the blocked. Remaining five will be the blocked. So what happened? Instead of blocking the okay, this blocking is done. So next memory packet able to send third packet. Yes or no. So this is a condition we call as ordering. So when you will send as a memory, if you get as a update flow controller next time, you can able to send again two, next one. Then after you can able to send them if you get a update flow control memory point of view, you can able to send memory. Then after you can able to send. So if you are sending, if you are putting as block, what happen? The performance will be reduced. You are taking more time. If you are sending memory packet after completion of mem right of seven, then you can able to read the packets means it's blocking. Memory is blocking. So what happened? The performance will be the reduced. So what happened? Let us I send as a membrane packets with the 2 nanosecond. So update flow control I got as a membrane with two headers I can able to send. So in that such a situation, third packet membrane packet you can able to send or not. That is the scenario we'll see as a ordering. So we are giving as a order and reorder. Order means first you have to send as a seven packets, then after you are sending as a three packets for memory. This is a we order, this is order, this is we call as a strong ordering. You have to follow in this order means this is a way. If you but what happen, you want to increase the performance, you don't want to block the packets. If you block the packets means it will more time to take from data sent from transmitter to receiver. Instead of that, let us I want to give as a relax ordering means first two packets I send as a membrane, third packet I want to send as a membrane instead of blocking. Is it possible case? So in this case we will say as a ordering rules. Let's take forward to the video. We'll go with the ordering rules. These are order rings we need to follow to improve the performance. So let us take where scenario. You have a RC, You have a EP, you are sending the packets, you maybe get the response based on that packets from EP to RC side. So let's take where scenario. Post, I told posted, non-posted. Posted, we have a posted with data, posted with messages, and non-posted with data and without data. Memory also there. Memory is non-posted without the data. IO write and IO reads are posted as I told. So that IO write means that is a non-posted, but its data is present. So this non-posted with the data we call as a IO. IO and config. We called as a config. We called as a with the data also present. And completion you will get as the from the let's take you want to read the data with 0 to 15 address, you will get as a response to that completion we called completion, you will get as a with the data you will get as a EP from RC side. So let's take a example here how ordering rules will helpful here to improve the performance. Let us you have a RC and EP. First packet will let us assume posted. Let us I want to sending as a posted packet. Again, next packet I can able to send posted or not. No, you cannot send the posted. Again, next packet will be the posted. No, this condition is no. This is the ordering rules. Back to back, you cannot send. You cannot send the back to back packets with the posted. But you can able to send yes and no condition. Here is a B. Posted first. This is the order you have to see from the top to down. Then after left to right. First packet will be the top to down, next packet will be the left to right. So you can able to send the packet, but where the condition, this is a to a to a, here is given a to a, the posted request must not pass the another posted request unless a to b is applies. So a to b applies, a to b applies. A to b means this is a way. A to B, the posted request must RO bit is set. RO bit means relax ordering. We are giving relaxation. No need to block the packets. Instead of blocking, you have to give as a relax to that packet. You can able to send the next packet as well with the posted packets. So you can when RO bit is a set in a TLP, we have a RO bit that bit need to be set. Then only you can able to send the next packet as a membrane packet. One more scenario where let us take scenario where let's take as a no slide. You have a RC, you have a switch, you have a two EPs devices connected to this lane. Two EPs as connected to different lane. This is a switch, this is a RC, this is a EP1. That ID will be the ID1. This is a EP2. This is a ID2. So first packet you are sending membrane packet, next packet also you can able to send the membrane packet, but you have to bit as a RO bit I. And one more will be the you if you have a in a order in this, one more point I want to add, if you are using same traffic class, we have a 8 different traffic class will be there. Like let us take where scenario, one example with the let us take you have a 10 trains in a station. First train, second train, third train, fourth train, five trains will be there. One, two, three, four, five. You have a outgoing only a single track is there. Let us take here we need to understand why ordering. Let us I want to if is it possible to use five trains at a time in same track? It's not possible, right? This condition, this situation we call as a deadlock. Single resource you cannot use multiple packets. If you have a five different packets, you have a only single path that we call as a traffic class. If you have a single traffic class, let us assume TS1 I am using, you have a 8 different traffic class, I am using only single track single traffic class. If you want to send different packets, it's not be the case. Like you have to give as a order, I want to send as a first train as a first, fifth train as a second, third train as a third, fourth train as a fourth, second train as a fifth. You are giving ordering, right? You if you give ordering, what happen, you are utilizing effective way of this path. effective way of using traffic class. If you are using 5 trains at a time with the same path means it's not be the case of utilization properly. It will be the deadlock situation. It will be the block. All the trains will block at a time. So instead of using that, we have to give as a ordering. Same scenario where here we are giving as a order. If we have a different EPs with different IDs. So what happen? You can able to send the membrane packets with same membrane packet with same traffic class. That possible is also there. But scenario where if you are using same traffic class, same ID, you are sending posted with posted means no. It's not be the case. If you introduce relax ordering, then only you can able to send the packets with same traffic class. This is the way you can have a table to send the pack back to back with posted with the posted. This is the case. Let's see the scenario where posted with non-posted. You can able to send the case. No, you cannot able to send. Let's see the A25. A2, A52, A5, A52. Where it is? The posted request permitted to pass completion. Let's see the posted request completion. A2B, A5A. Here, this is A5A. A5A. This is the case. The posted request is permitted to pass completion, but it's not required to able to pass completion unless A to B is applies. Let us take where scenario you have a RC, you have a EP, you are sending the packets, you will get a response from EP to RC side where A to B is applies. Yes, yes and no condition will be there. Yes condition also there. Let us take where scenario. Uh, let's take as a no slide. You have a RC connected with any memory, and you have a switch. You have a EP devices connected through LAN. This is a EP1. This is a EP2. This is a switch. You have a RC. You have a system memory. Here is the scenario. What is saying? This is the scenario. A5A. So the posted request is permitted to pass completion, but it's not required to be able to pass completion unless A to B applies. It's really the situation. Let us you are sending posted packets. Next packets you want to send as a completion. Is it possible? No. Yes and no condition. No. Or yes possible. But you have to use A to B applies. A to B means it's a situation where A to B. This is a to B. You are using some kind of bits or some bits have to be enabled to bypass that packet. So bypass means it's kind of instead of blocking the packets, you the situation here it's saying like you cannot send posted with next packet will be the completion. If you want to send the completion, you have to use some kind of it's kind of RO bit as set. Here is if you see in A to B, RO bit has been set. So based on that, you can able to yes and no condition also possible. So same scenario, you can able to pass instead of putting as a blocking, you can able to pass, but you have to follow some ordering. Some bit has to be enabled. So we'll see condition where is condition. This is a is condition. Non-posted request with pass with posted. This is a packet assumed as a membrane packet. Membrane packet. This is a packet assumed as a membrane packet. Yes, you can able to pass. Scenario where membrane packet back to back same class using you can able to send membrane packet. Next will be the membrane packet also you can able to send. So in this way, this order will be helpful. If you see in a next condition where let us take this scenario. Let this is scenario. Let us I am sending as IO packet. This is a IO packet. IO with the data means IO write I am doing. IO write I am doing. IO write I am doing. So next will be the completion. Completion means you are getting your RC will generating as a completion. How it's possible generating completion? Let us take scenario where EP is want to read the data from system memory to EP side. So EP will send as a mem read packet with, let us assume 0 to 15 address. So you will get as a completion, right? This data is coming from system to this RC will store that data. RC will generate as a completion. So if you are sending IO write packet here, next packet you will send as a completion, right? So here is the condition where IO write packet and completion. First packet will be the IO write, next packet will be the completion. Yes, you can able to send. So in this condition, back to back, you can able to send IO write or IO read, config write or config read. Back to back, you can able to send the completion as well. So using same traffic class. So by using this ordering rules, in this way you can able to see the scenario where actually we can able to send the packet, where actually need to be block the packets. So as I explained, one more point as a flow control. If you have enough packets, enough credits, you can able to send the packet. Even though ordering rules is working fine, if you have enough, if you don't have enough space, it's only that packet will be the blocked. So in this way, ordering rules helpful to improve the bring up the performance will be the high. So in this video I covered different type of package, posted and non-posted. Then I went through that flow control mechanism, how packets will be blocked using instead of sending membrane back to back membrane. So how it will be the blocking, how flow control is update flow control using DLLPs. Then after straightforward I explained with ordering rules table using the different type of packet. So in this video I covered in this overall ordering rules. If you have any question, please let me know. Thank you.